Right now, your brain is burning through roughly 20% of all the energy your body uses today. Just sitting there, just reading this, your brain alone eating up a fifth of your entire fuel supply. That should not be possible, not for an animal like you. Most primates cannot afford a brain this expensive. Their digestive systems are busy all day, all night, just breaking down raw plants, raw meat, raw everything. There is no energy left over to run a brain the size of yours. So, how did you end up with one anyway? The answer is not a bigger brain evolving first, then figuring out what to do with all that extra power. The answer is stranger than that. Something else had to change first. Something almost embarrassingly simple. Before a bigger brain could even become possible, go back roughly 2 million years. Your ancestors are eating the way every other primate eats. Raw meat, raw roots, raw everything, torn and chewed for hours just to extract enough calories to survive the day. Chewing raw food is hard work. Digesting raw food is even harder work. A chimpanzee today spends nearly half its waking hours chewing, just to get eno. Usable energy out of its food. Half its day, gone, just chewing. Picture that for a moment. Imagine spending 6, 7, 8 hours a day with your jaw working just to afford the calories your body needs to move, think, and survive until tomorrow. There is barely any time left for anything else. Certainly not enough spare energy sitting around to run an unusually large brain. Now imagine trying to run a brain that burns 20% of your energy budget on top of that. There simply isn't enough fuel left over. The math does not work. Something has to give. Compare that to almost any other large-brained animal on the planet. Elephants have enormous brains, but they also have enormous guts built to process massive quantities of raw plant matter around the clock. Dolphins have large brains too, but they burn a smaller share of their total energy on thinking than you do, and their diet of raw fish requires relatively little digestive effort to break down. Humans are the outlier. A primate-sized body, a brain wildly out of proportion to that body, and a digestive system too small, by primate standards, to explain where all that extra energy could possibly be coming from. Something does not add up unless you change one variable in the equation. Primatologist Richard Wrangham, who has spent decades studying the biology of early humans, proposed something that reframed this entire problem. He argued that the turning point wasn't a genetic mutation, or a sudden leap in intelligence, or some spark of insight that separated humans from every other primate. It was fire. Specifically, it was cooking. Here is what cooking actually does to food at a level most people never think about. Heat breaks down tough plant fibers before your teeth ever have to. Heat denatures proteins in meat, unraveling their tightly wound structure into something your gut can absorb far more easily. Cooking is, in a very real sense, outsourcing a huge portion of digestion to a fire instead of your own body. Wrangham's hypothesis, sometimes called the cooking hypothesis, suggests this shift happened far earlier than most people assume, potentially stretching back close to 2 million years, right around the time the human body itself begins to change in the fossil record. Smaller teeth, smaller jaws, a shorter digestive tract. All signs of a species no longer built to process large amounts of tough, raw food. Once digestion becomes easier, chewing time drops dramatically. Energy extraction from food goes up. And all of that saved time, all of that extra energy, has to go somewhere. It went to your brain. Anthropologist Leslie Aiello, working alongside Peter Wheeler, described this trade-off with something now called the expensive tissue hypothesis. The idea is straightforward once you see it. The human gut, compared to other primates, is unusually small. Smaller intestines, smaller stomach, less digestive tissue overall, relative to body size, than you would expect from a primate our size. That is strange, until you realize what filled the gap left behind. A smaller gut freed up metabolic energy that would otherwise be spent constantly digesting raw, tough food. And that energy was rerouted, almost like a budget reallocation inside the body, into a brain that could now afford to grow larger layer by layer, generation after generation. You did not get a bigger brain and then figure out how to feed it. You figured out how to feed a bigger brain and only then did evolution allow one to grow. Think about how strange that sequence actually is. The physical world, the fire, the food, the digestive system had to change before the mind could. Intelligence did not arrive first and invent cooking as a clever trick. Cooking arrived first, quietly making a bigger mind biologically affordable for the first time. But cooking did something else too, something even less obvious than energy. Biologist Rachel Carmody has run experiments comparing raw and cooked diets directly, testing how much usable energy animals actually extract from each. Her research shows that cooked food isn't just easier to eat, it delivers meaningfully more calories per bite than the same food eaten raw, even when the ingredients themselves are completely identical. In one line of her research, mice fed cooked meat gained significantly more weight than mice fed the exact same raw meat, despite eating the same amount. The food had not changed, only the way it had been processed before it entered the body. The fire wasn't just softening food, it was quietly increasing its value. This is part of why strict raw food diets, popular in some corners of modern wellness culture, tend to be so difficult to sustain long term. People following them often struggle to maintain their body weight, even when eating what looks, on paper, like plenty of calories. Your body, after roughly 2 million years of relying on cooked food, is no longer fully optimized to extract everything it needs from raw ingredients alone. The fire became part of the deal a long time ago. This changes the picture of what early humans were actually doing around those first fires. Not simply staying warm, not simply scaring off predators, though both of those mattered too. They were running the earliest known energy processing technology on the planet, one that effectively pre-digested their food before a single bite reached their mouth. Archaeological evidence for this shift is harder to pin down than you might expect, since fire leaves faint traces that can easily be erased over hundreds of thousands of years. But sites associated with early Homo erectus, a species whose brain size had already begun expanding beyond earlier hominins, show patterns consistent with controlled fire use stretching back at least 1 million years and possibly further. The timing lines up almost too well to ignore. Here is where the story gets even stranger. Cooking a meal takes time. It takes a fire that has to be tended, watched, protected from wind and rain. It takes someone gathering wood while someone else prepares food, and someone else keeping watch for predators drawn by the smell. Cooking, almost by necessity, could not happen alone. It had to happen around a shared fire, with other people, at a shared time of day, waiting together for the same reason. And once you have a group sitting still together for an extended period every single day, waiting for food to cook, you suddenly have something ancient humans never really had before in quite the same way. Unstructured social time. Time to communicate without the pressure of an immediate task. Time to teach a child how something works. Time to strengthen the bonds between people who depended on each other to survive the next hunt, the next winter, the next threat. The hearth may be one of the very first stages ever built for human connection. Long before language became as complex as it is today, the simple act of sitting still together, night after night, waiting on the same fire, may have laid the groundwork for the kind of deep, cooperative social bonds that few other primates ever developed. Notice what's happening here. A single discovery, learning to control fire and apply it to food, didn't just add calories. It restructured digestion. It restructured energy allocation inside the body. It restructured the size and shape of the human brain. And it restructured the shape of human social life, all at once, all from the same small flame. That is an extraordinary amount of change to come from something as simple as heat. And it did not stop mattering once your ancestors' brains finished growing. It still shapes you today, every single day, whether you notice it or not. Ask yourself something. Why does the smell of something cooking pull at you, even when you are not particularly hungry? Why do so many of your most important memories, holidays, celebrations, ordinary Tuesday dinners, revolve around a table with cooked food sitting in the middle of it? Why does a shared meal still feel like one of the fastest ways to turn strangers into something closer to family? Think about how much of modern life still orbits around this exact pattern. Business deals get closed over dinner instead of in a boardroom. First dates happen at restaurants instead of in silence. Entire television networks exist just to show other people cooking, plating, and eating food you cannot even taste. None of that is a coincidence. It is a several million-year-old instinct wearing modern clothes. Because the fire that once freed the energy to build your brain also became the anchor point for human connection. You inherited both halves of that discovery, the fuel and the gathering. Right now, your brain is doing something no other primate's brain can afford to do. It is thinking about itself. It is reflecting on a story that only exists because millions of years ago, your ancestors learned to place food over fire and wait. Not because they understood neurons, metabolism, or evolution. They simply discovered, one meal at a time, that life worked better this way. Over thousands of generations, that small habit reshaped bodies, reshaped brains, reshaped families, and eventually reshaped civilization itself. The next time you cook dinner, or gather around a table with people you care about, remember that you are participating in one of the oldest technologies your species ever invented. Not just a way of preparing food, but a way of building the very mind that is reading these words right now. Fire did not simply help humans survive. It helped create the kind of humans capable of changing the world. And in a very real sense, every cooked meal is still carrying that ancient flame forward.